All right, so example 1, we have Teo. Teo sketches a design of a quadrilateral shaped building. If angle 1 is supplementary to angle 2 and 4, is his design a parallelogram? So what we're doing is what's happening is we're given some information about our angles, and based on that information, is that enough for us to say that yes, we have a parallelogram? So let's explore what we know. We are talking about angles 1, 2, and 4. So here's angle 1, here's angle 2, here's angle 4. So angles 1 and 2, those are on the same side of this, what could be considered a transversal, and they are interior to this set of lines right here. So angles 1 and 2 are same side interior angles. Now, when your same side interior angles are supplementary, that means you've got a set of parallel lines. So angles 1 and 2 are same side interior angles. We can see that from the picture. And they did tell us that they are supplementary. And they're supplementary, so that means that if we take a look at here's angle 1, it's being formed by the bottom side and the left side. Angle 2 is being formed by the left side and the top side. So that left side would be the transversal, and because angles 1 and 2 are supplementary, that means that we have parallel lines. So the top side and the bottom side are parallel. So we can come over to our picture. We're saying that this side is now, the top is parallel to the bottom. So we don't have a parallelogram yet because we just have one pair of parallel sides, could be a trapezoid. So let's explore what else we know. We also were told something about angle 1 and angle 4. So if we look at the picture, angle 1 and 4 are on the same side of this bottom side, and they are inside these lines over here. So we've got another pair of same side interior angles. So angle 1 and angle 4 are, I'm going to go ahead and abbreviate SSI, they're same side interior angles. And then they told us that 1 is also supplementary to 4. So, and they're same side interior angles and they are supplementary. If your same side interior angles are supplementary, that means you have a pair of parallel sides or parallel lines. So if we look at what would be parallel, we're talking angle 1 and angle 4. The segment that connects them is the transversal, and what's forming the other side of each angle would be the parallel lines or parallel sides in this example. So in this case, the left and the right sides will be parallel. So do we have a parallelogram? Well, we just showed that opposite sides are parallel. We've got one pair of opposite sides parallel and we have another pair of opposite sides parallel. That gives us a parallelogram. So let's just conclude opposite sides are parallel. We just showed that to be true. So this is a parallelogram. Pretend that's what I just wrote. All right. So a second sketch, what is this, of a building? In a second sketch, the design has some different information. So let's go ahead and put the second sketch in here. I think it was supposed to be included as an image, but we'll go ahead. I'll show you what it looks like. So we've got, looks a little bit different. And we have angles 1, 2, 3, and 4. Okay, so in a second sketch, the design has angles 1 congruent to 3 and 2 congruent to 4. So let's just make a note of that. Angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So we're going to work through a bit of a mathematical proof to show whether or not we have a parallelogram. We do know that we have a quadrilateral. We have 4 sides. We also know that when you have a quadrilateral, the sum of those interior angles will be 360. Hopefully that's becoming a more common sum of interior angles for you. So what that means is if you add all the angles together, angle 1 plus angle 2 plus angle 3 plus angle 4, those are going to add up to be 360. Well, we also know since angle 1 is congruent to angle 3, they told us that in the question, and angle 2 is congruent to angle 4, we can use substitution to keep working with this equation. So let me show you what that's going to look like. So we're going to say angle 1 plus angle 2 plus, instead of angle 3, we're going to substitute in angle 1 right there because we know that those are congruent angles. And then plus, instead of angle 4, we're going to substitute in an angle 2 right here to equal 360. We're just kind of manipulating our equation based off of true facts that we know. Math does this a lot. If you notice, we have an angle 1 plus angle 2, and then we have another angle 1 plus angle 2. So how many of those angle 1 plus angle 2's do we have? We have 2 of those. 2 times angle 1 plus angle 2 equals 360. Well, let's go ahead and get rid of that 2 with division. We can divide. So we have angle 1 plus angle 2 is equal to 180. In our picture, we can see that angle 1 and angle 2 are consecutive angles right in a row. With substitution, we also can say that angle 1 plus, we know that angle 2 is congruent to angle 4, so we can replace that angle 2 with angle 4. That's also equal to 180. So all we did was we took this equation and we substituted angle 4 in for this angle 2. And if you look at our picture, angle 1 and angle 4 are consecutive angles. So when you have consecutive angles that add up to 180, that means they are supplementary. So that means that we have a parallelogram. So consecutive angles are supplementary. So that means this is a parallelogram, also just like the first picture. All right, so this gets us to just a couple theorems to take a look at. If an angle of a quadrilateral is supplementary to both of its consecutive angles, so that's what we showed up above. Angle 1 was supplementary to angle 2 and to angle 4. Those were both of its consecutive angles. Then the quadrilateral is a parallelogram. So up here you can see angle A plus angle B. Those consecutive angles are adding up to 180. And then angle A plus its other consecutive angle are adding up to 180. When that happens, then that means that ABCD is a parallelogram. All right, another theorem, converse to the opposite angles of a parallelogram. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So you can see angle A is congruent to angle C, angle B is congruent to angle D. So when that happens, then ABCD is a parallelogram.